Greetings, everyone. In the camera lens, the magic of the moment meets the precision of technology, immortalizing every heartbeat in a picture. Today, I'll be talking about my presentation about embedded systems in cameras. Introduction. Definition of embedded systems are specialized component systems designed to perform specific tasks. They are the brains behind many devices we use daily. Characteristics: com- compact and efficient, real-time operation, low power consumption, reliable, and cost-efficient. Examples of embedded systems: smartphones, touchscreens, cameras, and apps. Home applications: microwave, washing machines, automotive system, engine control, infotainment, and off-focus cameras. Embedded systems enable cameras to autofocus and stabilize image, process high-quality photos and videos, connect to other devices by using Wi-Fi and Bluetooth. Implementation of embedded systems in cameras. Development process. Requirement analysis. Understanding the specific needs of the camera. System design. Designing the hardware and software core architecturally, including selecting the right microcontroller, image sensor, and memory. Prototyping. Building a prototype to use the functionality of the embedded system. Testing and validation. Ensuring the system meets performance, power, and thermal requirements. Deployment. Integrating the embedded system into the final camera product. Tools and technology. Development boards. Use of development boards like Raspberry Pi, Nevada Jetson, or BeagleBone for prototyping. Programming language. Commonly used languages like C, C++, Python for embedded system software development. Real-time operation, RTOS for short. Use of RTOS for managing real-time tasks in cameras. Simulation tools like MATLAB or Simulink for simulating image processing algorithm before implementation. Case studies: smartphone cameras. How embedded systems are implemented in smartphone cameras for features like portrait mode, night mode, and AI-based scene recognition. AI-based recognition. Action cameras. Implementation of stabilization algorithm and power management in action cameras like GoPro. Surveillance cameras. How embedded systems enable motion detection, night vision, and remote monitoring in security cameras. Lifecycle embedded systems and cameras. Design development phase. Conceptualization, defining the requirements and goals of the embedded system. Hardware and software design, select components of designing circuit and writing firmware. Testing, rigorous testing to ensure the system meets performance and reliability standards. Manufacturing phase, producing mass production of the embedded system components. Quality control, ensuring each unit meets quality standards before being integrated into cameras. Deployment phase, integration, embedded system into the camera and ensuring it works seamlessly with other components. User training, providing user manuals and guides for operating the camera. Operation phase, monitoring regular firmware updates to fix bugs, improve performance, or add new features, troubleshooting, diagnosing and fixing issues that arise during the camera use, end of life phase, recycling and disposal, proper disposal or recycling of the embedded system components to minimize environmental impact. Legacy support, providing support for older camera models even as new ones are released. Role of embedded systems in cameras. Embedded systems are the backbone of modern cameras, enabling them to perform complex tasks efficiently. They act as the brain of the camera, controlling hardware components and process data in real time. Hardware control, managing sensors, lenses, displays, and other peripherals. Image processing, enhancing image quality through algorithms for noise reduction, color correction, and more. Use user interactions, providing an intuitive interface like touchscreen, buttons, and menus. Connectivity, enabling features like Wi-Fi, Bluetooth, GPS for sharing and G-tagging photos. Key components of embedded systems in cameras. Microcontroller slash processor acts as the central processing unit (CPU) of the camera. Examples: ARM processors, digital signal processors (DSPs), handles tasks like autofocus, image stabilization, and data compression. Image sensor convert light into electrical signals like comms, CSDs. Sensors works closely with the processor to capture high-quality images. Memory, RAM, temporary storage for real-time data processing. Flash memory stores firmware settings and captures images. Input-output interface. Input, buttons, touchscreen, and delays for user interaction. Output, LCD/OLED displays, HDMI ports, and USB connections. Power modules unit ensures efficiency power use to extend battery life, regulates voltage for different components. Microcontroller processor. A microcontroller is a single chip that includes a processing unit, some small amount of memory, and inputs and outputs to interact with computer peripherals. These small computers are often used to interact with larger systems or other microcontrollers, but many are robust enough to perform usual function on their own, including for use in embedded system. There are many microcontrollers available, all with different specs that make them optimal for use in specific areas, with some pros and cons to help you decide which might be right for your project. NVIDIA Jetson TX1, Raspberry Pi 3 Model B, NVIDIA Jetson TK1, Bagel Board or BeagleBone Black. Starting with NVIDIA Jetson TX1. This is what is considered the powerhouse of microcontrollers. It's a bit more expensive than the other options, but it has a robust community behind it and impressive specs that makes it ideal for use in embedded vision. Pros: impressive computation 1 teraflop, low power consumption 10 watt, 64-bit quad-core processor, onboard Wi-Fi and Bluetooth. Cons: being expensive. Raspberry Pi 3 Model B. Raspberry Pi has long been an affordable option for microcontrollers, and the performance and support of the Pi 3 are awe-inspiring. Pros: 1.2 GHz quad-core processor, very affordable, robust community of developers, onboard Wi-Fi and Bluetooth. Cons: low performance than TX1. NVIDIA Jetson TK1. This Jetson model, which came before the TX1, still has impressive computation power and a great ecosystem of developers behind it. Pros: very affordable, high computation power, 300 gigaflops, robust community of developers. Cons: no onboard Wi-Fi or Bluetooth, less performance than the TX1. Bagel board, BeagleBone Black. The Bagel board is an excellent option for embedded vision that requires additional hardware connection, and it still boasts impressive processing. Pros: highly expandable with hardware, affordable, high storage capacity. Cons: GUI is subpar, lower performance than prevision options. Image sensor. An image sensor or imager is a sensor that detects the convey information used to form an image. It does so by converting the variable attenuation of light waves as they pass through the objects or reflect off it into signals, small bursts of current that convey the information. The waves can be light or other electromagnetic radiation. Image sensors are used in electrical imaging devices of both analog and digital types, which include digital cameras, camera modules, camera phones, optical mouse devices, medical imaging equipment, night vision equipment, such as thermal imaging devices, radar, sonar, and others. As technology changes, electronic and digital imaging tends to replace chemical and analog images. As we see the parts of the camera here, cover glass, sensor chip, package, wire bond, and also contact pads. Image sensors, there's all the types, and for different types of cameras. Memory, as RAM and flash memory, as we mentioned before. In cameras, RAM is used for temporary storage of image data during processing. This includes buffering images before they are written to the storage card, storing data for image processing such as noise reduction and color correction, running the camera's operation system and software. Flash memory is a type of non-volatile computer memory. This means that it retains data even when the power is turned off. It's a solid-state storage device, meaning it has no moving parts, making it durable and reliable. Digital cameras use flash memory cards like SD cards, compact flash cards, and more to store the images and videos you capture. It all allows for easy transfer of files to computers and other devices. Input-output interfaces. Input-outputs or I/O interfaces in cameras are essential components that allows user to interact with the camera and enable the camera to communicate with the other devices. These interface facilitate the transfer of data, control signals and power between the camera and external device, input interface buttons, touchscreen, microphones, and sensors. Output interface displays HDMI, USB, and audio output. Connective interface Wi-Fi, Bluetooth, NFC, and GPS. Power interface battery compartments USB-C and DC input. Specialized interface hot shoe, PC, sync port, and Ethernet. Power Management Unit. The Power Management Unit, PMU, in cameras is a critical component of the embedded system that ensures efficiency and reliability, power distribution to all cameras hardware components. It plays a key role in optimizing battery life, regulating voltage, and managing power consumption, especially in poor cameras like DSLRs, mirrorless cameras, and action cameras. Key functions of Power Management Unit: voltage regulation, battery management, power saving modes, thermal management, power distribution. When you take a photo, the image sensor captures light and converts it into raw data. The processor processes the data, autofocus, noise reduction. The processed image is stored in memory or displayed on a camera scene. Connectivity models allow you to share the photo instantly. As we see here, light path, lens elements, rotation mirror, shutter, digital sensor, eyepiece, focusing screen, and pentamerism. These are the parts of the camera that function when you take a picture. Key features embedded by embedded system. Embedded systems are responsible for many of the advanced features that make modern cameras powerful and user-friendly. Autofocus and image stabilization. Autofocus says embedded algorithms analyze the scene and adjust the lens positions to ensure the sharp focus. Advanced systems use phase detection or contrast detection for faster and more accurate focusing. Image stabilization. Components for camera shake by using gyroscopes and accelerometers to detect motion. The embedded system adjusts the lens for sensor to stabilize the image, especially in low light conditions or while recording video. Key features embedded by embedded systems. Real-time image processing, noise reduction, reduces graininess in low-light photos using advanced algorithms. Color correction ensures accurate and vibrant colors by adjusting white balance and saturation. High Dynamic Range HDR combines multiple exposures to create a single image with better detail in shadows and highlights. Connectivity features as Wi-Fi and Bluetooth allow wireless transfer of photos and videos to smartphones, tablets, or computers. Enable remote control of camera via mobile app, GPSs. G-tags photos with location data for easy organization and sharing. User interface and experience. Touchscreen controls provide intuitive navigation throughout menu and settings. Customization button and DIAL allow photographers to quickly access frequently used functions. On-screen guides help beginners with composition, exposure, and focus. Advanced shooting modes. Burst mode capture multiple frames per second for fast action photography. Time lapse and slow motion. Embedded systems handle frame rate adjustment and stitching for creative video effect. Scene recognition automatically adjusts setting based on the detection screen for portraits, landscape, night mode. Types of cameras. DSLR cameras, high-end cameras with advanced embedded systems for autofocus, image stabilization, and high-speed shooting. Mirrorless cameras, as we mentioned before, compact cameras with embedded systems for real-time image processing and electronic viewfinders. Smartphone cameras, embedded system enable features like portrait mode, night mode, and AI-based scene recognition. Action cameras, embedded systems and action cameras like GoPro provide stabilizing, waterproofing, and high frame rate video recording. Surveillance cameras, embedded systems enable motion detection, night vision, and remote access. 360-degree cameras, embedded systems stitch together multiple images to create immersive 360-degree photos and videos. Thermal cameras, embedded systems process thermal imaging data for application in security, firefighting, and industrial inspection. Difference between cameras. You see here, Model DI, Model Dual, flash mount as it only exists in the camera on the left. Shutter release button as shared between them. Flash is shared. The body, lens, but stuff like aperture ring and focusing ring is only in the camera on the left. More camera parts like flash mount, LCD display, shutter button, function control, autofocus assist, memory card slot, digital sensor chip, off surveillance mirror, viewfinder, filter, lens elements, filter holder, zoom ring, focusing ring, lens release, function controls. As from the back, there are even more parts. Also buttons like control pad, still video toggle, live view, I button, zoom out, zoom in, lock, menu, drive, playback, delete, viewfinder, and adductor adjuster. Applications of embedded systems in cameras. While today's digital cameras capture images, smart cameras capture high-level description of the scene and analyze what they see. These devices could support a wide variety of applications, including human and animal detection, surveillance, motion analysis, and facial identification. Consumer photography. Embedded systems enable features like autofocus, image stabilization, and scene recognition in DSLR, mirrorless, and smartphone cameras. Surveillance and security. Embedded systems in security cameras allow for motion detection, night vision, and remote monitoring via Wi-Fi or IoT. Medical imaging cameras in medical devices, endoscopes, MRI machines use embedded systems for high-resolution imaging and real-time processing. Automotive embedded systems in dashcams, advanced drive assistance system ADAS enable features like lane detection, collision avoidance, and parking assistance. Drones and aerial photography. Embedded systems in drone cameras stabilize footage, enable GPS tracking, and process high-quality images and videos in real time. Industrial and scientific cameras used in manufacturing for quality control, robotics, and scientific research for high-speed imaging and data analysis. Marketing of cameras with embedded system. Unique selling points, USPSs. Advanced features highlight features like autofocus, image stabilization, real-time image processing, and connectivity like Wi-Fi, Bluetooth, GPS. Ease of use. Interfaces user-friendly. Interfaces, touchscreen control, and customizable buttons. Innovations showcase cutting-edge technology like AI-based scenes, recognizing 4K, 8K video recording, and computation photography. Portability markets the compact and lightweight design of mirrorless and action cameras. Durability. For action cameras, emphasize ruggedness, waterproof, and shock resistance. Marketing channels. Digital marketing used for social media platforms like YouTube or TikTok to showcase high quality images and videos captured by cameras. Influencer partnership, collaborating with photographers, vloggers, and tech influencers to demonstrate the camera's capabilities. Retail and e-commerce, selling through online platforms, Amazon, B&H Photo, and physical stores with in-store demonstration, trade show and events, participation in photography expos, tech conference and trade shows to showcase new products. Marketing of cameras with embedded systems. Brand positions, high-end markets, brands like Canon, Nikon, and Sony position their DSLR and mirrorless cameras as professional guard tools for photographers and videographers. Consumer market. Brands like GoPro and DJI target casual users and adventurers with action cameras and drones. Smartphone integration. Companies like Apple and Samsung market their smartphone companies as all-in-one solution for everyday photography and social media, all in your phone. As we see the graph here, Canon is the leading company with a low decrease in sales, while Sony, even though it's in second, it's only 27% of the market, is still increasing, while Nokia is decreasing. Fujifilm, Fujifilm, one of the lowest, has potential, while Panasonic is is in a still state. And as we notice, majority of these companies are Japanese. Types of consumers: professional photographers and videographers. Needs: high quality image and video output. Advanced features like autofocus, image stabilization, and raw image support. Preferred cameras: DSLR and mirrorless cameras with high-end embedded systems like Canon EOS R5, Sony Alpha series. Marketing focus and emphasize technical specification, lens compatibility, and professional grade performance. Enthusiasts and hobbyists, such as myself, needs cameras that offer a balance between professional and ease of use, with room for creative experimentation. Preferred cameras: mid-range mirrorless cameras and advanced compact cameras like FJI Film X-T30, Sony RX100. Marketing focus: highlight versatility, creative shooting modes, and user-friendly interface. Is casual users and social media enthusiasm. Needs easy to use cameras with good image quality for everyday photography and social media sharing. Preferred camera: smartphone cameras, point and shoot cameras, and entry level mirrorless cameras. Example: iPhone 14 Pro, Canon PowerShoot G7X. Marketing focus: emphasize convincing connective features like Wi-Fi and Bluetooth, and AI-based enhancement like portrait mode and night mode. Adventurers and action seekers need durable, portable cameras that can capture high-quality footage in extreme conditions. Preferred cameras: action cameras and drones, GoPro Hero 11 and DJI Osmo Action. Marketing focus: highlights ruggedness, waterproofing, stabilization, and high frame rate video recording. Types of cameras. And the last one is security and surveillance. Professional needs cameras with motion detection, night vision, and remote monitoring capabilities. Performed cameras, surveillance cameras, and security cameras, AR low, Nest Cam. Marketing focus: emphasize reliability, advanced detection, algorithms, and integration with smart home system. Challenges in designing embedded systems for cameras. While embedded systems are enable advanced features in cameras, designing them comes with several challenges. Power consumption. Challenge: cameras, especially portable ones, rely on batteries, making power efficiency critical. High performance processors and connectivity consumes satisfaction power. Solutions use low power processors and optimize software to minimize energy use. Implement power saving mods when the camera is idle. Thermal management challenges high performance processors and image sensors generate heat, which can affect performance and damage components. Overheating is especially problematic in compact cameras with limited airflow. Solution: use heat-sink thermal pads or fans to dissipate heat. Implement thermal throttling to reduce performance temporarily and prevent overheating. Size and cost constraints challenge cameras, especially compact and mirrorless models, have limited space for hardware components. Solution: use minimized components and system on chip (COC) designed to save space. Feature trends: the future of embedded system in cameras is exciting, with advancement in technology driving innovation, AI and machine learning integration. Embedded AI will enable smarter features like screen recognition, object tracking, and automatic editing. Enhanced communication, 4G, 5G, and IoT integration will allow cameras to upload and share content in real time. Example: live streaming high quality video directly from camera. Minimization and improved efficiency. Smaller and more energy efficient components will make cameras even more portable and powerful. Advanced image processing, real time 8K video processing, and computation photography will become standard. Sustainability, eco friendly materials, and energy efficient designs will become a priority. In conclusion, embedded systems are the heart of modern cameras, enabling advanced features like autofocus, image stabilization, or real-time processing. They have transformed photography, making it more accessible, creative, and powerful. As technology continues to evolve, embedded systems will drive even more innovation in cameras, pushing the boundaries of what's possible, whether you're a professional photographer or a casual user. The future of cameras is bright thanks to the incredible power of embedded systems. Thank you. Thank you for listening to my presentation.